In this session, I discuss the idea of production function in general and Cobb-Douglas production function in particular. Production function is a very important idea in economics, especially in microeconomics and macroeconomics. And we all know that economics deals with the activities of economic agents such as households and firms, or individuals and firms. And hence we are so interested in the relations that underlie the activity of production. And we all know that for conducting production, we need factors of production or inputs. So production function simply means the functional relationship between inputs or different factors of production and the output. And when we think about the factors of production or inputs, we know that several factors of production are there, such as labor, capital, organization, then land, and a long list can be added. But all in all, the most important factors of production are labor and capital. And labor is the foremost factor of production. So, when we think about the function relationship between factors of production and output, we consider labor and capital. And also remember that it's a functional relationship. Because of that, we say that it is production function. So functional relationship means actually it's a concept from mathematics. There is no need to worry about the use of mathematics, because generally in social sciences, especially in economics, we consider mathematics in a very broad sense as a language with which we represent or communicate certain phenomena in a very precise manner. And also in many situations, the phenomena cannot be explained in a descriptive manner. So when we attempt to explain or describe such phenomena in a descriptive manner, so a lot of ambiguity, lot of confusion may happen. So when we use mathematics in such situations, we can represent and convey the idea, or we communicate about the phenomenon in a more precise and accurate manner. So that's only the purpose of mathematics in economics. So we represent production function as y equals a function of L and K. And we know that y stands for output or income, and F stands for the functional relationship, L stands for labor, and K for capital. So simply speaking, this is the simplest representation of production function in economics. Once again, the definition of production function is that we understand production function as the functional relationship between labor and capital, or the factors of production and the output. Okay. Now we move to discuss the idea of Cobb-Douglas production function. And Cobb-Douglas production function is considered as one of the simplest representation of production function in economics, and it is very easy to understand. The underlying logic is very simple and is very interesting also. So this idea has been developed by two social scientists, Cobb and Douglas. Cobb means Charles Cobb, Douglas, Paul Douglas. Actually, this research work has been started by Paul Douglas. He was an economist. So when he undertook his research study during the early 20s, he was working as a temporary faculty member at Amherst College of University of Massachusetts. So he studied about the share of labor, the share of capital in the output of United States. And what is the meaning of share of labor and share of output and share of capital? So simply means, suppose the total output is 100, then we want to know, out of this total output 100, or the value of production, how much of that 100 rupees is going to laborers and how much is going to the owners of capital. So that is the idea of labor share or capital share. ഈ ഒരു കാര്യത്തിൽ നമ്മളെല്ലാം തന്നെ അങ്ങേയറ്റം അറിയാൻ ആഗ്രഹമുള്ള ഒരു കാര്യമാണ്. നമുക്കറിയാം, ഉൽപ്പാദനം എന്ന് പറയുന്നത് ലേബറും ക്യാപിറ്റലും ഉപയോഗിച്ചാണ് ഉൽപ്പാദനം നടക്കുന്നത്. ഉൽപ്പാദന ഘടകങ്ങളായ ലേബറും ക്യാപിറ്റലും ഉപയോഗിച്ച് നടത്തുന്ന ഉൽപ്പാദനത്തിൻ്റെ മൂല്യം എത്രയാണെന്നും അങ്ങനെ ഉൽപ്പാദിപ്പിക്കുന്ന മൂല്യത്തിൻ്റെ വിഹിതം ഉൽപ്പാദന ഘടകങ്ങളായ ലേബറിനും ക്യാപിറ്റലിനും എത്രമാത്രം ലഭിക്കും എന്നുള്ളതും അറിയുക ഒരു താല്പര്യമുള്ള കാര്യമാണ്. അതിനെയാണ് ലേബർ ഷെയർ എന്നോ ക്യാപിറ്റൽ ഷെയർ എന്നോ നാം വിളിക്കുന്നത്. ഷെയർ ഓഫ് ലേബർ ആൻഡ് ക്യാപിറ്റൽ ഇൻ ദ ടോട്ടൽ ഔട്ട്പുട്ട്, ഇൻ ദ വാല്യൂ ഓഫ് ദി ടോട്ടൽ ഔട്ട്പുട്ട്. സോ ഫോർ എക്സാമ്പിൾ, കൺസിഡർ ദ ടോട്ടൽ വാല്യൂ ഓഫ് ദി ഔട്ട്പുട്ട് ഈസ് 100. 100 രൂപയുടെ ഉൽപ്പന്നമാണ് ഉൽപ്പാദിപ്പിച്ചതെന്ന് വിചാരിക്കുക. അങ്ങനെയാണെങ്കിൽ ആ 100 രൂപയിൽ എത്ര രൂപയായിരിക്കും അല്ലെങ്കിൽ എന്ത് വിഹിതമായിരിക്കും ലേബറിന് ലഭിക്കുക, എന്ത് വിഹിതമായിരിക്കും ക്യാപിറ്റലിന് ലഭിക്കുക. അപ്പോൾ ഇതറിയുക എന്നുള്ളത് വളരെ പ്രധാനപ്പെട്ട ഒരു സംഗതിയാണ്. So it is in this aspect Paul Douglas also got interested and he conducted his study. He studied about the time series of labor, capital and output of US economy for a period of 23 years, starting from 1899 to 1922. And after his study, analysis, he came to a very interesting conclusion that the share of the labor to the total output remained as a constant proportion throughout the period. നമുക്ക് അദ്ദേഹത്തിൻ്റെ സ്റ്റഡി ഒന്ന് നോക്കാം. വി ക്യാൻ സീ ദി പേപ്പർ പബ്ലിഷ്ഡ് ബൈ പോൾ ഡഗ്ലസ് ആൻഡ് ചാൾസ് കോബ്. സോ ദിസ് ഈസ് ദ പേപ്പർ, തിയറി ഓഫ് പ്രൊഡക്ഷൻ ബൈ ചാൾസ് കോബ് ആൻഡ് Paul Douglas. So Charles Cobb was at that time working at Amherst College, and Paul Douglas, by the time of the publication of the paper, he has been moved from Massachusetts University to University of Chicago. So actually this paper has been published in 1928. So this very interesting finding actually motivated Paul Douglas to explore the phenomenon in more detail. Paul Douglas ഈ പ്രതിഭാസത്തെ ഇങ്ങനെയാണ് റെപ്രസെൻ്റ് ചെയ്തത്. WL equals alpha y. W stands for wage rate and L stands for number of labor units. And alpha a proportion and y is output. And see that the finding of Paul Douglas is that share of labor remained as a constant proportion of the output. So this idea can be mathematically represented as WL equals alpha into y. So here alpha stands for that proportion of y. So this much has been immediately developed by Paul Douglas. But actually he wanted to know what is the underlying relationship that gives this particular result, or what is the underlying functional relationship between inputs and output. And he immediately understood that it requires more mathematical skills. So he has a friend in the Department of Mathematics of Amherst College of Massachusetts University, and that mathematician was Charles Cobb. So he discussed this finding and this phenomena with Charles Cobb, and Charles Cobb immediately came with a mathematical representation of the relationship between factors of production or inputs and outputs, which gave this particular result. So let us see that. The initial representation given by Paul Douglas is WL equals alpha into y. Douglas. Then the underlying relationship has been suggested by Charles Cobb as y equals a into L raised to alpha into k raised to 1 minus alpha. So this is given by Cobb, Charles Cobb. Now the question is, how can we connect the Cobb-Douglas production function or the function given by Cobb to the initial observation of Paul Douglas? So for that purpose we make few more assumptions, that there is perfect competition in the economy and the firm is a profit maximizing firm. We have seen the representations given by Charles Cobb and Paul Douglas. The initial representation of Paul Douglas is WL equals alpha y. Here this alpha is a constant, implies that share of labor is a constant proportion of output. The representation by Cobb-Douglas is y equals a into L power alpha into k power 1 minus alpha. Now the question is, how can we connect the representation given by Cobb with respect to the initial representation given by Cobb-Douglas? So for that purpose, we have to represent the profit function and to maximize it. So the profit function will be pi equals yp minus wl minus k into r. Pi stands for the profit, y is the output, and p is the general price level, so that will be the market value of output. Then w stands for the wage rate and L is the units of labor used. So the product of W and L will give the share of labor. K stands for the number of units of capital and R is the rate of return on or the remuneration of capital services. So the product of K and R will give the share of capital. So this expression shows that out of the market value of output, when we subtract the share of labor and the share of capital, what remains will be the profit. Now to maximize this profit, we have to follow the rules of differentiation, differential calculus. See here, two independent variables are there, the labor and the capital. So we have to take the first derivative of the profit function with respect to labor and capital. But for the time being, we take only the first derivative of the profit function with respect to labor alone. A curious student is advised to take the first derivative with respect to capital also and see what happens to the final result. So for the time being, we take only the partial derivative with respect to labor alone. So the partial derivative of this function will be del pi by del L equals P into del Y by del L plus Y into del P by del L minus W into del L by del L minus L into del W by del L. So these del L will be cancelled out. So we simplify the expression as P into del Y by del L plus Y into del P by del L minus W minus L into del W by del L. Now note this expression. This expression shows that, implies that price depends upon labor. But there is no such direct dependency of price upon labor. Instead, what we know is that Y depends upon labor. We write it as Y is a function of labor. Similarly, we also know that Y or quantity depends upon price. That is, Y is a function of P. So it is on the basis of this second relationship we take the price elasticity of demand. But instead of this relationship, we take the inverse of that. So we write it as price depends upon Y and Y depends upon labor, or generally we write it as P is a function of Y and Y is also Y is a function of L. More specifically, P is a function of Y and Y is a G of L. So since price depends upon Y and Y depends upon L, there is a chain relationship is there. So with respect to the derivation of this second term, we have to follow the chain rule. So we write it as del pi by del L equals P into del Y by del L plus Y into del P by del y into del y by del L. So this is the chain rule. This is nothing but the chain rule. Minus W minus L into dW by dl. So we have completed the derivation. Now we set this equation equal to 0. Set the equation equal to 0 to fulfill the first condition of maximization. So we get implies P into del y by del L plus y into del P by del y into del y by del L equals minus plus W plus L into del W by del L. Now note that we have del y by del L in the first term and also the same thing in the second term. So to simplify this expression, we take the first term entirely as a common factor. So P into del y by del L as a common factor. Then their first term is taken as the common factor. So we give 1 as the first term. So in the second term there is no P. But we have here taken P as a multiplying factor. So to neutralize that effect, we divide the second term with P. So it will become y by P into del P by del y. Bracket ends. Similarly, the first term W is taken as the common factor. So 1 plus. So here W is multiplied with the terms inside the bracket. But for the second term there is no W. To neutralize the effect of that multiplication, we divide the second term with the W. So it will become L by W into del W by del L. Now note these entities. These two entities are actually inverse elasticities. Now consider the elasticity, price elasticity of quantity demanded. Price elasticity of quantity demanded. So that has been defined as percentage change in quantity demanded divided by percentage change in price. So we write it as dy by dp into p by y. Now consider these entities. So the entity in the orange circle is exactly the inverse of the entity given in the black circle. So the black circle, inside the term inside the black circle represents the price elasticity of quantity demanded. And what we have inside the orange circle is its inverse elasticity. Now consider that in perfect competition, the elasticity of quantity demanded is very high. We take it as infinity. Then what would be the inverse of infinity? The inverse of infinity will be 1 by infinity. So we know that 1 is divided by a term which is larger and larger and larger. So eventually it will become 0. It will equal 0. It will tend to 0. It is not equal to 0. It will tend to 0. So which means that since the terms inside the orange circle are inverse elasticities, both will be equal to 0. The term inside the second orange circle is price elasticity of labor, or more specifically wage elasticity of labor demanded. So that two terms will be equal to 0. So we write it as P into del y by del L, 1 in the bracket, equals W into 1. So we write it as just P into del y by del L equals W. Therefore we write del y by del L equals W by P. Then what is this entity? W is wage rate and P equals price level. So if P is the general price level or the appropriate price deflator, then W by P will give the real wage rate. Then what would be del Y by del L? Then we know that in perfect competition, real wage rate will be equal to the marginal product of that factor. So del Y by del L becomes the marginal physical product of labor. Now let us see how we can connect this expression with the underlying functional relationship between input and output as given by Charles Cobb. So we recall the functional relationship given by Charles Cobb. Y equals A into L raised to alpha into K raised to 1 minus alpha. So this is the popular Cobb-Douglas production function. So to make the connection, we take the first derivative with respect to L. So del Y by del L equals alpha into A into L raised to alpha minus 1 into K raised to 1 minus alpha. So we rearrange it as alpha into A into L raised to alpha into L raised to minus 1 into K raised to 1 minus alpha. So again we write it as alpha into A into L raised to alpha into K raised to 1 minus alpha divided by L. See, L raised to minus 1 became 1 by L by following the rules of exponents. Now see that this portion of the numerator is y itself as given in the Cobb-Douglas production function. So we rearrange it as dy by del y by del L equals alpha into y by L. So this becomes expression 1. Now recollect the expression that we have arrived at earlier. It has del y by del L equals W by P. So this is expression 2. So it is very clear that the RHS of these two expressions are same. So we equate them. W by P equals alpha into y divided by L. Now we cross multiply. Then we get WL equals alpha into y into P. So this is the expression, the relationship initially made by Cobb-Douglas. WL represents share of labor. P stands for general price level. So what happens is that Y into P represents the market value of output. So it is in this manner we arrive at the initial relationship, the representation made by Cobb-Douglas out of the underlying functional relationship defined by Charles Cobb. So this derivation is very interesting because of the reason that it gives a clear idea regarding how does theoretical contributions in economics have been made. See, initially there is no mathematics has been applied. At the very first instance, Cobb-Douglas studied about the time series of labor, capital and output of US economy. So his time series study showed that a particular pattern with respect to the share of labor and output. So in order to give a summary explanation for that pattern, he came with the representation, he came with the relationship W into L equals alpha into Y. But that is not enough. Why does such a particular pattern, a constancy in the share of labor happens? with respect to the output, more explanations are needed. What is the underlying functional relationship between inputs and outputs has to be unearthed. So for that purpose, he has took the help of his friend and mathematician Charles Cobb, and finally came with the celebrated Cobb-Douglas production function. So now it is clear that the intuitive economic insight is the very basic aspect of Cobb-Douglas production function, even though we represent the relationship with the help of mathematical tools. And because of that, initially I have pointed out that mathematics is something like a language for studying economic behavior. Regarding the Cobb-Douglas production function, y equals a into L raised to alpha into k raised to 1 minus alpha. Here y stands for output, a is the state of technology, or also called as the total factor productivity, TFP. And what is alpha, or what is the value of alpha? The value of alpha is taken as alpha greater than 0 less than 1. Then alpha is contribution of labor to output, and 1 minus alpha equals, hence becomes the contribution of capital to output. Then we have seen that A stands for the state of technology. The state of technology means the commonsensical understanding regarding state of technology is that it is the manner in which the available factors of production are combined in the process of production. So we have labor and capital. Suppose there are two firms, and suppose both these firms have same units of labor and capital. Say for example 100 units of labor and 1000 units of capital. But the production of these two firms may be different. The first firm may be producing 10,000 units, while the second firm may produce 15,000 units, depending upon the manner in which each firm is combining labor and capital for the final production. So because of that, we consider it as the state of technology. Now regarding the properties of Cobb-Douglas production function. The first property of the Cobb-Douglas production function is that if the value of labor and capital is 0, then obviously there will not be any output. And also we can see that when we increase the value of labor and capital, there will be increase in output. So this becomes the first property of Cobb-Douglas production function. That is, if labor and k equal to 0, y will also be equal to 0. Okay. Then when we increase labor and capital, if labor and capital increases, y also increases. Now the important property. So these two are, even though this can be understood by having a visible observation of the underlying Cobb-Douglas production function. So the important property of the Cobb-Douglas production function is that it displays diminishing returns to factors of production, as diminishing returns to factors of production. So that can be proved by following few mathematical steps. We consider the Cobb-Douglas production function as y equals a into L raised to alpha into k raised to 1 minus alpha. So we take the first derivative with respect to labor. For the time being, we consider capital. We are differentiating with respect to labor alone. So this will become del y by del L equals alpha into a into L raised to alpha minus 1 into k raised to 1 minus alpha. Now this can be written as alpha into a into k raised to 1 minus alpha divided by L raised to 1 minus alpha. This is so because by following the rules of exponents. The rule of the exponent says that L raised to alpha minus 1 can be represented as 1 by L raised to minus alpha minus 1. So which can be represented as 1 by L raised to minus alpha plus 1. That can be rearranged as 1 divided by L power 1 minus alpha. So because of that, we write this expression as something like this. Now this can be simplified as del y by del L equals alpha into A into K bar divided by L, the whole raised to 1 minus alpha. The reason we have given a sign, a bar sign over K, showing that it has been taken as constant. So in such a situation, what happens if it increases labor? Now the LHS, del y by del L, we have earlier seen that this can be represented as the marginal physical product of labor. So what happens is that when we increase labor, and since the numerator is K bar, its value is constant. So when we increase labor, the marginal product of labor will continuously fall. So this is what we say that there is diminishing returns for labor with respect to the Cobb-Douglas production function. So the same will happen to capital also. So we summarize that something like the third property or the most important property of Cobb-Douglas production function is that it displays diminishing returns to factors of production. The fourth property of Cobb-Douglas production function is that when we increase one factor of production, the marginal physical product of the other factor increases. So the third property is that there is diminishing returns. So we have seen that happens because one factor is kept constant. But instead of that, if we increase that factor of production also, then the marginal product of the other factor of production will increase. Then we have seen that the A in the Cobb-Douglas production function represents the state of technology. Now the property is that when there is an increase in A or the value of A increases, or when there is a favorable change or a positive change in A happens, the marginal productivity of both the labor and capital increases. In writing, when A increases or changes favorably, the marginal physical product of labor and capital also increases. Now the sixth property of Cobb-Douglas production. So that sixth property of Cobb-Douglas production function is related to the power of labor and capital. So we have written it as L raised to alpha and K raised to 1 minus alpha. Earlier we have seen that alpha stands for the contribution of labor to the output and 1 minus alpha similarly represents the contribution of capital to output. So that can be also considered as alpha and 1 minus alpha. Both can be considered as elasticity of output with respect to labor and capital. And if alpha plus 1 minus alpha equals 1, then we say that this production function will display constant returns to scale. And for Cobb-Douglas production function, alpha plus 1 minus alpha will be equal to 1. So it's a constant returns to scale. The production function displays constant returns to scale. Production functions are classified into 3 on the basis of how output responds to equal proportional increases in inputs. We have seen that in the case of Cobb-Douglas production function, alpha plus 1 minus alpha is equal to 1. So we say that Cobb-Douglas production function displays constant returns to scale. So we have 3 different types of production functions. One is the production function having constant returns, then increasing returns and decreasing returns. So what is the intuitive idea behind constant returns to scale? This means that if you increase the inputs by 10%, the output will also increase by 10%. So that is called as the constant returns to scale. And for Cobb-Douglas production function, since the value of alpha plus 1 minus alpha is equal to 1, we have constant returns to scale. In the case of increasing returns to scale, if we increase the inputs by 15%, for example, then the output will increase by 20%. So that is called as increasing returns. Then we have the decreasing returns, where suppose if we increase the inputs by 15%, the output is increasing only by 10%. So on the basis of how output responds to equal proportional increase of inputs, we classify the production functions into 3 types: constant returns to scale, increasing returns to scale, and decreasing returns to scale. So these are the 6 important properties associated with the Cobb-Douglas production function. Now we are moving to the critical comments regarding the production function. So one of the foremost critical comments raised against the production function has been made way back during 1960s by the celebrated Cambridge economist Joan Robinson. So Joan Robinson simply argued that production function is actually a neoclassical construct which makes a lot of miseducation. This is the main criticism leveled by Joan Robinson against all types of production function. The reason is that actually she is focusing upon the conceptual issues involved production functions. How does we measure output? Again, how does we account different types of labor required for production? So production functions simply assume that all labor units are homogeneous, but it is not like that. Similarly, with respect to capital, for any production, we need different types of capital. So how can we aggregate all that different types of capital into a unified one? So she said that production functions are theoretical constructs of neoclassical economics, which makes miseducation among the scholars of economics. Then again, one more fundamental criticism that has been leveled against the production function during the time of Paul Douglas and Charles Cobb was made by none other than Ragnar Frisch. We know that Ragnar Frisch is a towering personality in econometrics. He is generally considered as the father of econometrics. So we know that Cobb-Douglas production function is the result of an empirical study, is the result of an econometrical analysis. So Ragnar Frisch says that since the study involves only few data points, that is only 23 years. So 23 years, some 23 data points are there. A period starting from 1899 to 1922. So for such a small set of data, whatever be the finding, however interesting it may be, it has only limited value before making generalization. So all these criticisms point out the very important fact that when we make policy decisions on the basis of Cobb-Douglas production function or whatever be the other types of production functions, we must be very careful. But at the very same time, we have to consider that even though these problems are very important issues, cannot be brushed aside, still this concept of production function gives a reasonable approximation of the complex phenomena that we are dealing with in the area of production. So these findings can be considered as approximation, reasonable approximation. So the caution must be, whenever we make policy decisions on the basis of production functions, we must be very careful. We have to consider the consequences of such decisions upon the various aspects of the economy. മറ്റൊരർത്ഥത്തിൽ പറഞ്ഞാൽ, ഉൽപ്പാദന രംഗത്ത് നിലനിൽക്കുന്ന ഉൽപ്പാദന ഘടകങ്ങളും അന്തിമ ഉൽപ്പാദനവും തമ്മിലുള്ള ബന്ധത്തെ വലിയ കുഴപ്പമില്ലാത്ത രീതിയിൽ അവതരിപ്പിക്കാനും വിലയിരുത്താനുമൊക്കെ ഈ പ്രൊഡക്ഷൻ ഫംഗ്ഷൻ എന്ന ആശയം നമ്മളെ സഹായിക്കുന്നുണ്ട്. പക്ഷെ അങ്ങനെയൊക്കെ ആകുമ്പോഴും ഈ പ്രൊഡക്ഷൻ ഫംഗ്ഷൻ എന്ന ആശയത്തെ സൃഷ്ടിക്കുന്ന ലേബർ, ക്യാപിറ്റൽ, ഔട്ട്പുട്ട് ഇവയെല്ലാം എങ്ങനെ കണക്ക് കൂട്ടിയെടുക്കുന്നു, ഇവയെല്ലാം എങ്ങനെ നിർവചിക്കുന്നു എന്നുള്ളതൊക്കെയായി ബന്ധപ്പെട്ടിട്ടുള്ള അടിസ്ഥാനപരമായിട്ടുള്ള സങ്കല്പനപരമായിട്ടുള്ള പ്രശ്നങ്ങൾ വളരെ ഗൗരവത്തിലുള്ളതാണ്. അതുണ്ട് എന്നുള്ളത് കൊണ്ട് തന്നെ പ്രൊഡക്ഷൻ ഫംഗ്ഷൻ എന്ന ആശയത്തിൻ്റെ അടിസ്ഥാനത്തിൽ നമ്മൾ ഏതെങ്കിലും നയപരമായ തീരുമാനങ്ങളിലേക്കൊക്കെ കടക്കുമ്പോൾ വലിയ രീതിയിൽ ജാഗ്രതയുള്ളവരായി മുന്നോട്ട് പോകേണ്ടതുണ്ട്. ഈ കാര്യമാണ് ജോവാൻ റോബിൻസണും റാഗ്നാർ ഫ്രിഷുമൊക്കെ മുന്നോട്ട് വെക്കുന്ന ഈ വിമർശനാത്മക വിലയിരുത്തലുകളിൽ നിന്ന് നാം ഉൾക്കൊള്ളേണ്ട പാഠം. So with this remarks, I wind up the discussion on production function in general and Cobb-Douglas production function in particular. Thank you.